So, welcome back, all viewers. Today, we are going to discuss about the next topic of Thyristor. Yesterday, we have seen about Thyristor. So, let's flash back in memory. So, Thyristor. Introduction, Thyristor turn on method, Thyristor gate characteristics, Thyristor rating, as well as improvement of Thyristor characteristics, heating, cooling, and mounting of Thyristor, series and parallel operation of Thyristor, low power Thyristor, firing circuit for a Thyristor, gating circuit for a single phase converter, pulse transformer triggering, cosine firing scheme, ideal characteristics of power electronic device. So, Thyristor turn off methods, Thyristor characteristics. Actually, this content already we discussed in previous session. So, anode voltage rating during the blocking state of a Thyristor. So again, whenever we need to analyze the characteristics, then the most of the time characteristic draw into two axes. X-axis, that is horizontal axis, and y-axis, that is the vertical axis. So always, or we can say most of the time, we draw our characteristics between two axes, x-axis and y-axis. Current rating, average on state current, conduction angle 180 degree in a bracket minus t by 2t into 360 degree. Form factor, conduction angle. What is the formula for conduction angle? T upon n and t into 360. So that is conduction angle. So that's why here is a 360, because the total degree of any circle is 360. And what is the degree for half circle? 180. 0 to 180 degree. So there is a numerical on the Thyristor. Also we have Thyristor protection. First is di by dt protection. Then the another one is dv by dt protection. dv by dt and di by dt protection. Design of Snumber circuit. Snumber circuit. Example: overvoltage protection, internal overvoltage, external overvoltage, suppression of overvoltage. Again, there is any characteristics, we can say waveform, not waveform, voltage ampere and volt resistance, characteristics of voltage clamping device. B, action of current limiting fuse in any AC circuit. Overcurrent protection, electronics crowbar protection. Again, gate protection. Gate, what is gate? So gate is the terminal. With the help of this terminal, we can control our triggering of thyristor. So that's why here we are using the gate terminal. And anyway, the main difference between the thyristor and the transistor. So in a transistor there is a three terminal, that is the base, collector and emitter. But in case of thyristor there is a again three terminal, but the name of base replaced by the gate. Okay. So this is the major difference in a transistor and a thyristor. And what is the main difference between them? So where where the quantity of the power is too much, then we are generally use thyristor. And the quantity of the power is we can say moderate, then there we are using transistor. So this is the basic logic behind it. Okay. So again we have numericals. And one great advantage for the numericals is there is a clear cut possibilities of marks. Means if you can solve the numericals, then definitely you can get full marks. And you don't have any idea about the formula, then definitely you get 0 marks. So clarity in the numericals is too much high. So that's why numerical gives us maximum marks if and unless when we learn the formulates which is required for the solving of numericals. So again we have actually this topic also I read in previous content, improvement of thyristor characteristics. So improvement of thyristor characteristics, how we can improve the characteristics. Improvement in a di by dt rating, higher gate current. So with the help of this method we can improve the thyristor characteristics. Main thyristor turn on by pilot thyristor, means we are going to connect pilot thyristor across the main thyristor. Structural modification of the device, improvement in a dV by dt rating, normal discharge current, thyristor cathode short, elementary, intermixing. So again heating, cooling and mounting of thyristor. Actually this is a theoretical part, heating, cooling and mounting of structure. I think so. As per GATE exam concern, theoretical concept is also important, but the condition is that first of all we need to understand the deepness of thyristor expression. Then we should go on this theoretical part. Again anyone who are preparing for the GRE, then they can take any advantage for this concept: series and parallel operation of thyristor, series connected SCR, silicon controlled rectifier. SCR stand for silicon controlled rectifier, means. And what is the role of rectifier? Rectifier is the static device which can convert AC power into DC power. Rectifier name suggests rectify the AC pulses into DC pulses. Okay, actually rectify means conversion of power, but the important thing is that if we need to convert DC power into AC power, listen me carefully. DC power into AC power, suppose we need to convert, then we use always converter, not rectifier. We need a conversion of DC power into AC power, most of the time in an inverter. So inverter is an example of converter. Okay, in our home basically we use inverter for the load shedding purpose. When our power getting cut or gone, then our inverter getting on, and our little bit load, not 100% load, little bit load we run with the help of inverter. Calculation of capacitance C. We have the formula VBM equals to Q2 minus Q1 upon C equals to del Q upon C. Thyristor is two interesting topic who are really like power electronics. Midpoint reactor. Again we have numericals. SCR with a rating of 1000 volt and 200 ampere are available to be used in a string to handle 6 kilovolt and 1 kilo ampere. Calculate the number of series and parallel unit required in case. Deteriorating factor. Solution A. Deteriorating factor DRF equals to 1 minus string efficiency 0.1 equals to 1 minus 6000 upon ns into 1000 equals to 1 minus 1000 upon np into 200. So number of series connected SCR, ns equals to 6000 upon 1000 into 0.9 equals to 6.6 is equals to 7. Means consider 6.6 is nothing but the 7, round figure. Number of parallel connected SCR NP 1000 upon 200 into 0.9 equals to 5.5, and consider 5.5 is nothing but the 6. As above, number of series connected SCR and number of parallel connected SCR NP equals to 1000 upon 200 into 0.8 equals to 6.25 is nothing but the 7. Means here we take any average value, or not average value, round figure value with higher value of DRF, and more SCR are required, and therefore voltage and current shared by each device are lower than their normal rating. This increases the string reliability, thus at any increased investment. Example, it is required to operate 250 ampere SCR in a parallel with 350 ampere SCR with their respective on-state voltage drop of 1.6 volt and 1.2 volt. Calculate the values of resistance to be inserted in series with each SCR so that they share the total load of 600 ampere in a proportion to their current rating. Solution: dynamic resistance of 250 ampere SCR 1.6 upon 250 ohm. Dynamic resistance of 350 ampere SCR 1.2 divided by 350 ohm. Let R be the resistance inserted in series with each SCR with this current share by 1.2 upon 350 plus R 600 and current shared by SCR 600 1.6 upon 250 plus R upon total resistance is directly proportional to 350. Okay, from above 1.2 upon 350 plus R upon 1.6 upon 250 plus R equals to what equals to say to us 250 divided by 350 equals to 5 by 7. Okay, 5 by 7. Low storage, phone may slow down. We got notice. We can say notice or we can say alert. Alert and notice, I think so both are different thing, but anyway. Low power thyristor, programmable unijunction transistor, PUT, programmable. In the world of information technology, our power devices converted into programmable. So again, schematic diagram and circuit symbol of PUT, programmable unijunction transistor, silicon unilateral. Anytime our content can be automatically stopped due to space issue. So if this kind of sudden close occur, then consider our issue is space issue. Thyristor types. What is the types of thyristor? So as I can see here, there is a 13 types of thyristor. Phase control thyristor, or simply we can say SCR, fast switching thyristor SCRS, light activated silicon control rectifier LASCR, bidirection triode thyristor. Triode, what is the name suggests to us? Triode. Tri means 3, di means 2, mono means 1. Okay. Penta, what is the meaning of penta? Penta is nothing but the 5. So bidirectional triode thyristor triac. Symmetrical thyristor ASCR, reverse conducting thyristor RCT, gate turn off thyristor GTO, gate turn off thyristor GTO. FET, controlled thyristor FET CTH, static induction thyristor, and MOS control thyristor MCT. MOS, what is the stand for MOS? Metal oxide semiconductor control thyristor MCT. Very good thing, we have the 13 types of thyristor types. Again 12th number, emitter turn off thyristor ETO. Emitter turn off thyristor means, are you getting this concept? Emitter turn off thyristor. Basically, uh, take an example of thyristor, then we can there is a different methods of turn on as well as turn off. So these are the method, that is metal oxide semiconductor turn off thyristor, MTO. Okay, emitter turn off thyristor, ETO, integrated gate commutated thyristor, IGCT, integrated gate commutated thyristor, IGCT. Got it? These are now described one after the other. Phase control. So these are the brief, total 13 thyristor. So bidirectional triode thyristor, constructional features, and M2, MT2 plus MT terminal. Okay, gate turn off thyristor, statics, IV characteristics. IV stand for current and voltage. Current and voltage. I stand for current and V stand for voltage. Switching performance. Gate turn on, gate turn off, gate turn on, gate turn off. Basic GTO turn off circuit. Basic GTO. What does GTO stand for? Simply just turn the page and catch it. GTO. Gate turn off thyristor. Okay. Gate turn off thyristor. Here we have the three diagrams A, B, C, and I can see here there is a three terminal. First one is anode, second one is cathode, and third one is gate. That is the important terminal in point of view thyristor, because gate is responsible for the triggering. And what is triggering? Triggering is nothing but the operation. We convert off state into on state. So that is the any operation. Gate turn off thyristor. Basic structure, simplified schematic diagram, circuit symbol, static IV characteristics. IV stand for current and voltage. Gate turn on, gate turn off, voltage and current waveform during turn on and turn off of a GTO. Comparison between GTO and thyristor. Pretty much interesting topic as per my view. I don't know about you, what is your deepness of interest. Basic structure of any MCT. So what does MCT stand for? MCT stand for MOC, metal oxide. Oh, not MOE. Metal oxide MCT stand for metal oxide semiconductor controlled thyristor, MOS. MCT, metal oxide semiconductor controlled thyristor. ETO, emitter turn off thyristor. Anytime our connectivity may be break for the permanent time for this content. What is the formula for frequency? F equals to 1 by T. F equals to 1 by T. Formula for the frequency. Consider any frequency for India. So what is the frequency for India? 50 Hertz. Means what is the frequency show us? Frequency show us the speed of electrons. in the conductor. Suppose my electron flow with the speed of 60, then I can say my power frequency is 60 hertz. Again, hertz is the unit for frequency. So yes, frequency is nothing but the speed of electron, and we can describe formula for this frequency. F equals to 1 by T. T stand for time. Time. What is time? Angular momentum. Take any example, any kind. Suppose take any example of sinusoidal wave. Then when I apply my current to particular circuit, then my electron flow from one point to another point. Means there is any transportation of electrons, or we can say movement of electrons, because we cannot see with the help of our human eye of movement of electrons. We can see the movement of electron but not a transportation. Means suppose consider any example. We can see the boat in the river traveling. Means boat, we can actually see the boat in the river, but we cannot see electron in the conductor. So this is major problem for us. So that's why we cannot use transportation. We can use movement of electron. Okay. So again, frequency formula equals to 1 by T equals to 1 upon RC in into Vs upon Vs minus Vp, bracket complete. Try firing circuit. Actually, we need device. First, second, third, and fourth one. Firing circuit for a triac using a diac. Diac stand for die. Die means double. Triac stand for tri. Tri means triple. Commercial triac firing circuit using a diac. Gating circuit for single phase converter. Pulse transformer. Triggering. Triggering means I have already explained about the triggering. I think so I need to improve my communication skill little bit, not because the fluency of my language is, I think so, not good, but in average I think so. Most important thing is that concept, but I need to maintain such a kind of communication so that you can listen me properly and take any interest in our content, or we can say in our topic, not content. We are not here for the entertainment. We are going to face our important topic in the world of power electronics. Thyristor, king of the power, we can say. Natural commutation, it is also known as line commutation, or you can say commutation, or class F commutation. Natural commutation can occur when converter circuit are fed to from either single phase source or from three phase source, maybe single phase or three phase. Class A or resonant commutation. Force commutation. Again, we have the numericals on this concept, thyristor turn off methods. We have circuit, we have one thyristor and one load, that is the LCR. No, load is only resistive load R, and in a load there is any LC component, that is inductance and capacitance. Means in a load there is a two component, that is inductance and capacitance. Thyristor class A resonant commutation. Class B commutation circuit diagram and waveform. Class B commutation, or we can say self commutation. Class C, or complementary commutation. Here Vs equals to 200 V, R1 equals to 10 ohm, R2 equals to 100 ohm. So these are the numericals. For the circuit shown in figure, Vs equals to 200 volt, L equals to 0.2 millihenry, C equals to 20 microfarad, constant load current IO equals to load current IO. Load means input. Yes, load is the input or output. Actually load requires power, means actually load consume our power. So what is load? I think so load use our power, right? So load is any input device, right? Again we have the waveforms for the circuit of class E commutation or external pulse commutation. Much interesting topic. I think so lots of question on thyristor, near about 5.78, or lots of question 100, 100, 5.119. And our next topic, phase controlled rectifier. Phase controlled rectifier we are going to discuss in this chapter. Introduction, principle of phase control, full wave controlled converters, single phase full wave converters, single phase two pulse converter, and discontinue load current. Performance parameters of two pulse converter, single pulse symmetrical and asymmetrical semi converter, three phase thyristor converter. Again, performance parameters of three phase full converter. So are you getting this point? Full converter, I already clear. Where there were use converter, we should click in our mind there is any conversion of DC power into AC power. Okay, not any AC power into DC power, because if AC power into DC power, then we use rectifier. Okay, so rectifier is a static device which can convert AC power into DC power. dual converters, control of single phase series converter. Some work example. Principle of phase control. So what is phase? First of all, because in the world of power electronics, we should clear our basic in the sense basic electronics, then applied electronics, then topic of power electronics. Okay, so power electronics is the top higher level electronics, so that's why we should all this basic related to electrical as well as electronics. Actually nowadays our electrical system is also fetching to electronics, that is the power electronics we can say. Take any example of energy meter. uh, if we see our meter past 40 years, then not 40 years, take consider 20 years ago or 25 years ago, then 25 years ago our meter is purely analog meter, analog. And what is the difference between analog and digital? So digital having more accuracy as compared to analog meter. So this is any major difference between analog and digital. And nowadays world move from analog to digital. And digital is more efficient than the analog meter. But some places nowadays also use analog meter due to some limitation. Not limitation, but some places use. Input power factor. Single phase half wave circuit with RL load. RL means resistive inductive load. Single phase half wave circuit with RLE load, circuit diagram and voltage and current waveform. Single phase 2 pulse midpoint converter. Three phase converter. Single phase full wave converters. Here is the single phase supply, and we can convert into three phase. Most interesting topic. Single phase we have thyristor, three phase supply, and 1 2 3 load. Single phase 2 pulse bridge converter, three phase single pulse bridge converter. A delta zigzag transformer feeding a three phase 3 pulse thyristor converter. Three phase semi converter. power circuit for a three-phase semi-converter feeding CRLE load. Again we have waveform, voltage and current waveform for a three-phase semi-converter for a different firing angles. Volt MI. DC equivalent circuit of a single phase full converter, semi converter as well as full converter. Three phase full converter bridge. What is bridge? So bridge is the combination of more than two thyristor or two. Take an example, not example, thyristor or transistor. One message, again message, that is the power is also not enough. We have only 20% power in our device. P equals to 2. Dual converters. We are seeing now phase control rectifier, PCR. We are seeing now PCR. Dual converter without circulating current. HF, THD, HF. Phase control rectifier, and we have the multiple choice question. Can I read 1-2 question? Okay, we are going to read 1 or 2 question. First question: a single phase half wave controlled rectifier has a 400 sine 314T as the input voltage and R as the load for a firing angle of 60 degree. For the SCR, the average output voltage is A 400 by pi, B 300 by pi, C 240 by pi, D 200 by pi. So what is the answer? Can I repeat this question? A single phase half wave controlled rectifier has a 400 sine 314T as the input voltage and R as the load for a firing angle of 60 degree. For the SCR, the average output voltage is A 400 by pi, B 300 by pi, C 240 by pi, C 200 by pi. So what is the answer? Single phase half wave controlled rectifier. (6.1) Answer is B 300 by pi. 300 by pi. And what is the value for pi? 3.14. Value for pi 3.14. Maximum engineer dealing with pi. Maximum engineers. So just I clear the value of pi. 3.14. 22 by 7 is nothing but the 3.14. And I think so we don't have interest in reading of second question, that is 6.2. I think so. Uh, any any person who who are really want to create interest in this subject, then this guy or this candidate can be paste the page and written simply your I mean to say not complicated subject, but this subject you feel little bit like boring or not create interest in this subject, then you can write for this thing. You can write this thing. Just my suggestion, you can write for this topic or this chapter or unit, or we can say subject, or you can say yes, only subject. So you can write, I love too much. Take an example, engineering mathematics, and read this sentence day in a day one time. Okay, I love too much engineering mathematics, or I love too much engineering mechanics, or whatever subject you unable to create interest in this subject, then this trick is effective trick. And I realize I need to share the tricks with you, so that's why I share this trick with you. All right, again next topic is DC chopper. And chopper is nothing but the um, particular chopper deal with DC quantity, direct current quantity. Introduction. Uh, Again in this chapter we are dealing with introduction, principle of chopper operation, control strategy, setup step up chopper, types of chopper circuit, steady state time domain analysis of a type A chopper, Thyristor commutated chopper, multi-phase chopper name. When you listen this name chopper means chopping. And what is chopping? Chopping is the process in which we are slicing our signal. Slice, I think so. I give you example in a yesterday. Chopping means slicing. You see, while cutting the vegetables, we are chopping these vegetables for our sabji. Okay, so alpha equals to T on upon T, that is duty cycle. So all right, we are going to stop here, and our chapter is DC chopper. Also we are interested in the next chapter, just overlooking DC chopper, steady state time domain analysis of type A chopper, DC chopper. Our next topic, inverters. Our next topic is inverter. So inverter is the device which convert DC power into AC power. Most of the domestic appliances in home, we use inverters for the running of our load while our main power is cut, for the maintenance purpose or emergency purpose. Maintenance as well as emergency. Okay, got it. So all viewers, we are going to stop here. Keep reading, keep learning, keep growing, keep spreading this knowledge across the your family, friends, or any person who need the knowledge. I think so every person need knowledge. Just we need to just we need to show our demand. Okay, all right, thanks a lot.